Okay, then let's start today's tutorial. Okay, let me check it's recording or not. Yeah, it is recording properly. So let me solve the question number 1. Okay. Yeah, let me solve the question number 1. Question number 1, it is, suppose probability density function density function of a continuous random variable x is symmetric about the origin. Then which one of the following my screen is visible, right? Okay, so then which one of the following statement is true? So A, expectation of that variable is 0. B, x and 1 minus x, x and minus x have the same distribution. Distribution, and C is x and 1 minus x have the same distribution, or D, E, x always exist. So at first look it may appear that this first option is true, since this is symmetric about first option, or the D is always true, that it is symmetric, so Ex always exists. But this is not the case. There are certain probabilities which are symmetric in nature but they don't have the ex does not exist. So one of example is the example is let me yeah the example is Cauchy's distribution. So these does not always exist. Example is Cauchy's CAU Cauchy distribution, which is in the form whose PDF is f of x equal to x is 1 by pi gamma 1 plus x minus x0 by gamma square. So you can see this distribution is symmetric about x0, but if you want to calculate its mean expectation of x, it does not exist. So that means at the first appearance it seems ex always exists. This is true, but actually this is not true. So let's check what these actually say, that x is symmetric about origin. That means is PDF should be f minus x or equal to of x. In case of this, it is symmetric about x0. So in place of x0 you put 0. So then you can easily check that this condition is satisfied, that is f minus x equal to fx. And that means the distribution the b is always right, that x and minus x have the same distribution. Now let's check this is the b is the correct answer. So if you suppose draw a distribution so which is symmetric about 0, or rather then you will see that the distribution at plus x or minus x same. Now you can another things you can also observe that the cumulative distribution from 0 to minus x will be same 0 to plus x. Let me check it. So integration of 0 to minus x f of minus x dx, I think it is in opposite way. So this is minus x to 0 fx dx. You see this is equal to 0 to x fx dx. So that means the cumulative distribution of 0 to x and 0 to minus x to 0 equal to 0 to x. So the B is the correct answer. Now let's move towards the question number 2. Question number 2. Question number 2 is a printed page in a book contains 40 lines and each line have 50 positions. Now a typist make one error per 40,000 positions. Now assume that the distribution of number of errors per page follows Poisson distribution then what is the probability a page has no error? So let's see. So in a printed book, a printed page contains 40 lines and each line have 50 positions. So how many positions in a page? So total positions is 50 into 40, which is 2000 positions are there. Now these typist makes one error per 4000 positions. So what is the rate of error per page will be? So 2000 into 1 by, so if he make one error per 4000 positions, so if he type 2000 positions, what is the rate that he will make a mistake, that or the probability that in a single page there will be a error? It is half. So this is the rate, and assume that the distribution of the error follows the Poisson distribution. That means if a certain page has suppose n error, what is the probability then? E to the power minus lambda to the power n by n factorial. So here lambda is half, so e to the power minus half to the power n by n factorial. So what is the probability a page has no error? That means we have to calculate px equal to 0, which is e to the power minus half to the power 0 by 0 factorial, which is e to the power minus half. So that is basically 0. Here this is the lambda, so 0.6065. so this is the answer of the question 2. That's it. So now move toward the question number 3. A system consists of several components connected in series parallel with following from node A to B. So the connection is A. There has a these three components are in series, and these two components also in series, and these two are in parallel. So this point is A, this point is B. Now let's see, and these the reliability is every component is 95, it is 0.90, this is 0.92, this is 0.85, and this is point again 95. Now what is the total reliability of this network? Let's calculate it. So we know that for this series component the reliability will be for this series component, suppose this is some R, yeah, its answer is 0.0958, right? So this is suppose R, this is suppose S. So what is the reliability of the R? What is the reliability of R? It is the reliability of these 1, 2 and 3. So seen in series, R1 into R2 into R3. So that is 0.95 into 0.90 into 0.92, which is 0.8075. And what is the reliability of A's? This whole, this is R3 and R4 and R5, which is 0.85 into 0.95. This is basically okay, this is not, this is 0.7866, this is 0.8075. Then what will be the reliability of these two components which are in parallel? So let's see that. So reliability of this whole will be, that is 1 minus reliability of this R, 1 minus 0.7866 into 1 minus 0.8075. So this is basically 1 minus 0.2134 into 0.1925, and that is 1 minus 0.04107995, which is equal to 0.95 89, and so the reliability of the whole network is 0.9589. So you are correct. The correct answer is 0.958. Now let's move towards the next question. Question number 4. The times to failure in month X of the light bulbs produced at two manufacturing plants are and is of a company obeys exponential with min 4 2 months respectively. So plant R produces 3 times as many bulb as plant is the company mixes the produce bulbs at produced bulbs from the both the plants before selling. So now what is the probability? What is the probability? What is the probability that a randomly selected bulb from the mixed will work for at least 4 months. So now let's calculate that. It has been said that two bulbs are produced with a mean 4 and 2 months. So first, and the probability of these the failure follows the exponential. So that means the probability density of R x equal to t is 1 by 3 e to the 1 by 4 e to the power minus t by 4. Another is f of s x equal to t is 1 by 2 e to the power minus t by 2. And what is the probability of probability of producing a bulb from the plant R is, since suppose that it is x, suppose that probability of producing a bulb, that means I want to write the probability. What is the probability that if I selected a bulb from this mixed collection, what is the probability that bulb from the plant R? So that probability, suppose it is x. Now it has been said that the probability of the plant R produces 3 times as many bulbs as R. So that means if it is x, so x plus, okay, let me write it. So suppose that the bulb produced by this plant is S, then from this condition that plant R produce 3 times more, that means P of R should be 3x. Now that means PS plus PR should be 1, because in the mix there are only 2 types of bulb, one is coming from S, one other is coming from R. So that means 4x is equal to 1, that means x equal to 1 by 4. So that is P of S equal to 1 by 4 and P of R is 3 by 4. Now now another things, what is the probability that, let us calculate the probability that the bulb produced from the R plant will have a will work for at least 4 months. So that probability will be probability that it is produced from R is greater than 4 is actually 1 minus probability of R x less than equal to 4. So 1 minus, this is actually 0 to 4, 1 by 4 e to the power minus t by 4 dt, which is 1 minus of minus e to the power minus t by 4 0 to 4, which is 1 minus 1 plus e to the power minus 4 by 4, so e to the power minus 1. And similarly, what is the probability that bulb produced from the S will have a life more than 2? Similarly, 1 minus probability of S x less than equal to 2, which is 1 minus 0 to 2 half e to the power minus t by 2 dt, which is similarly e to the power minus 2 by 2. So e to the power, e to the power, it is actually 4. So what is the probability that its life will be greater than 4? So this is 4. So this is 4 by 2 to the power minus 2. Now we have to calculate the probability that if I select a bulb from the mix that will work at least 4 months. So we have to calculate the probability that bulb will work from more than 4. So we have to calculate the probability. What is the probability that bulb will work if it is produced by the factory R, and what is the probability of bulb producing at R plus bulb will work for greater than 4 that it is produced from S, and what is the probability of this. So if we do that, it is actually e to the power minus 1 into 3 by 4 into 3 by 4 plus e to the power minus 2 into 1 by 4. So if I calculate it, it is 0.30974. So this is the answer. Yeah, its answer is you are saying the answer is 0.30. It's not 8, it is 3.097. How do you say it? Okay. So that's it. Now let's move toward the question number 5. Suppose that the lifetime eggs in years of a new brand of industrial machine follows a gamma distribution with scale parameter scale parameter 2 and shape parameter 2 manufacturing plant installs a new machine determine the probability that the machine will still be in operation after 10 years. So let's see. So probability density function that follows a what distribution? Gamma distribution, right? So it is let me so gamma distribution, it is supposed to let it right t. So gamma distribution is lambda to the power r t, t to the power r minus 1 by gamma r e to the power minus lambda t. So here it has been said the scale parameter is 2. Scale parameter means the what is the scale parameter means what is time scale at. So that means here the scale parameter is 1 by lambda. For this distribution scale parameter is 1 by lambda because t into lambda should be a thing which is has no unit. So that means it's something no unit. So how the time scaled as 1 by lambda. So lambda will be that parameter, that is 2. So lambda is 1 by 2 and r is also 2. So then the distribution will become lambda to the power r, that means half to the power square into t2 minus 1 e to the power minus t by 2 2 minus 1 factorial, so which is 1/4 t e to the power minus t by 2. That's it. Now we have to determine the probability that it is still working after 10 years. That means what is the probability fx t greater than 10, that is, oh sorry, not t greater than, this is not true. So the probability of this machine work greater than 10, that will be 1 minus probability of x less than equal to 10. So if I calculate it, 1 minus 0 to 10 1/4 t e to the power minus t by 2 dt. Now let's calculate this integration. 0 to 10 t e to the power minus t by 2 dt. We'll integrate by parts. So first t e to the power minus t by 2 minus 2 will come. So let me write it properly. So here first t integration 0 integration over e to the power minus t by 2 dt, its limit will be 0 to 10 minus first differentiation of this term dt of t and integration of this minus t by 2, again this also 0 to 10. Now this integration will be minus 2 t e to the power minus t by 2 0 to 10 minus this is integration here minus 2 e to the power, this is 1, this integration result will be same 2 e to the power minus t by 2 dt 0 to 10. So that is minus 2 into 10 into e to the power minus 5, this will be 0 and minus this is again minus 2 into again minus 2 e to the power minus t by 2 0 to 10. So this is minus 20 e to the power minus 5 minus 4 e to the power minus 5 plus this is plus 1. So this is 1 minus, so this is not 1, this is 4 actually. So this is 4. So 4 minus 24 e to the power minus 5. Now if I put it here, then p of x greater than 10 will become 1 by 4, 1 minus 1 by 4 minus 4, 24 e to the power minus 5. So 1 minus 1 plus 6 e to the power minus 5. So 6 e to the power minus 5. So the answer will be 6 e to the power minus 5. So that's it. Please solve the normal distribution problems. Okay, today I gonna solve this the assignment 4. So next week I'll solve the problem regarding the normal distribution. I think the the problems associated with normal distribution is in the assignment 4. Or if you have any problem in your mind, any particular problem in your mind, then you can ask me now. If I can try to solve it, that's all. So if you have any particular problem regarding the normal distribution, you can ask me. Otherwise I will solve this week, I suppose it is week 4 assignment, which in which there is no problem associated with normal distribution. So I'll go to the question number 6. And is let x1 x2 x2n be independent random variable drawing from the uniform distribution 0 1 random variables. Let x r are equal to 1 2 to 2n denote the rth largest among x1 x2 to x2n. x2n, then which one of the following is correct? Two options are these: A, x1 is beta 2n, 1, B, x2n are beta 1 comma 2n, or C xr follows beta r 2n minus r plus 1, excuse me, or D xr follows beta 2n minus r plus 1 comma r. So let's see it. Yeah, so it has been said that these x are denote the rth largest among the these. So and the every variable x1, x2 or x2n is drawn from the uniform distribution 0 to 1. Then what is the probability that any of these variable less than or equal to t is simply t, right? Now suppose that the probability of these x are, what is then the probability that the largest largest rth random variable x r will be greater than t, that has to be that if I draw r minus 1 variable, these there if x r, the rth largest variable, is greater than t, that means the r minus 1 variable should be there which are lesser than t, right? So that means the probability, what is the probability that there are in this, from these 2n numbers, from 2n, what is the probability from 2n I draw r minus such random variable which is less than or equal to t. So what is the probability that any one random variable is less than equal to t? That is simply t. So what is the probability will be? The probability will be simply, the probability will be simply summation k equal to 0 to r minus 1 to n c k t to the power k 1 minus t to the power 2n minus k. So that's it. Now what will be the then if the xr distribution is like that, so what will be the cumulative distribution of the xr? Cumulative distribution of xr, that is, what is the probability xr less than equal to t will be, its probability is 1 minus p xr greater than t, and that is 1 minus this function p xr greater than t. Now from here we can calculate the cumulative distribution. We know this for t is nothing but t of tt p of xr less than equal to t. So that will be minus t dt of p xr greater than t. Now if we derivative each term, then we will see that all the term will cancelled and only the term survive, that is, that term will be 2n factorial by r minus 1 factorial into 2n minus r plus 1 factorial t to the power r minus 1 into 2n minus r plus 1 into 1 minus t to the power 2n minus r. So this is 2n factorial by r minus 1 factorial into, this will cancel, this will be 2n minus r, it's factorial t to the power r minus 1 1 minus t 2n minus r, and this is a beta distribution, which is beta r 2n minus r plus 1. So that means this is a beta distribution with parameter r and 2n minus r plus 1. So C is the correct answer. Now let's move towards the question number 7. Suppose if you ask any question. Okay, no question so far. Suppose if x PA PDF of the form of the form BDF of the form fx f(x) equal to k e to the power minus x by 2 by 2, or x is minus infinity to plus infinity. And what is the value of k? Now from the property of the probability that it should be minus infinity to plus infinity, fx dx should be 1. Now let's calculate. So to be 1, what will be the value, what should be the value of k? K minus infinity to plus infinity e to the power minus mod x2 by 2 to 1. Let's put x minus 2 equal to y. So then it will become k minus infinity to plus infinity to the power minus y by 2 dy equal to 1. Now this is mod. Now since mod y is a even function, this is a even function, so this will become 2k 0 to infinity e to the power minus y by 2 dy equal to 1. That means 2k minus e to the power minus y by 2 0 to infinity should be 1. So that means 4k minus e to the power minus infinity plus 1 equal to 0. So that means 4k, this is actually 0, so 4k should be this 1, so 4k should be 1, so that means k is equal to 1 by 4. So the value of the k should be 1/4, then this probability distribution follow this probability property, so the value of the k is 1 by 4. That is the correct answer. Now let's move toward the question number 8. Suppose hazard function of a system is ht equal to lambda, where lambda greater than 0 is a constant. Let t denotes the survival time of the system then the PDF, we have to determine what is the PDF of t will be. So let's calculate. So first we know that what is the hazard rate means. Hazard rate means what is the probability that its survival probability should be greater than t or less than equal to t plus h by h, right? Set, yeah. So this is so this is the hazard rate. This is ht. Now it is given ht is, so this means now this is means what is the this okay, now what is the probability? This probability is nothing but the probability that okay, so hazard rate means, yeah, so this is so this is means what is the probability that x will be, so let me write it in another way. So then this is the probability, we have to calculate it from the probability rule. So that means here it means we can write it in another way. What is the probability that x is less than t plus h, given that it is already, x is already greater than t, right? That means we have to calculate that. Now this means this is a, yeah, okay, so this is probability of, okay, let me check it. Hazard rate means, okay, so I got it wrong. So hazard rate means, yeah, hazard rate means the 1 by h limit h tends to 0 probability that t greater than t less than t plus h, given that t is greater than. So that is the hazard rate. Now this means that if this event is A and this event is B, and that means limit h tends to 0 1 by h, this is nothing but since this is an event which is a subset of this B event, so this is PA intersection B by PB, so that means limit h tends to 0 1 by h, and since A is a subset of B, that means the intersection will be A, so that means probability of t less than t t plus h divided by probability of t greater than t, and this is nothing but the 1 minus ft. So limit h tends to 0 1 by h, probability t less than t, and this is 1 minus ft. Now we know that this is the probability density PDA probability density function definition of limit h tends to 0 1 by h, probability to less than t is in between, this is the density function, so that is nothing but ft t by 1 minus ft. Now this is d dt of ft t by 1 minus ft, so this will be minus log of 1 minus ft. And it is given that minus log of 1 minus ft is hazard rate. This hazard rate, it is lambda, a positive constant, so that means 1 minus ft will be e to the power okay. No, I think this yes, so there is a, so this is d dt of this, so d dt of this, so this means log of 1 minus ft is integration minus lambda dt plus some constant, so this is 1 minus ft some constant a into e to the power minus lambda t. Now at t equal to 0, we input the boundary condition t equal to 0, ft is equal to 0, t equal to 0, ft is equal to 0, so then ft is equal to 1 minus a minus lambda t, so if t equal to 0, t equal to 0, ft equal to 0, 1 minus a, so a is 1, so that means ft is 1 minus e to the power minus lambda t. So that's it. Then what will be the probability PDF probability distribution function? So ddt of ft, that is actually ftt, so this is ddt of 1 minus e to the power minus lambda t, so this is minus ddt of e to the power minus lambda t, so this is plus lambda e to the power minus lambda t. So this is the solution for t greater than 0, and for t less than 0 these probability distributions will be 0. So that means the probability distribution function ftt is 0 for t less than equal to 0 and is lambda e to the power minus lambda t greater than 0. So that's it. So let's move toward the question number 9. Okay, question number 9. Okay, question number 9. So a point X is chosen at random from the interval yeah. So you have a question that suppose X follows a normal distribution with mean 0 and standard deviation 2, then the distribution of y e to the power x is a gamma function with mean positive and standard deviation, gamma with mean positive and standard deviation e to the power minus 1. Okay, and the second question is, let x be a normally distributed random variable with mean 0 and variance 4, then distribution of y ya plus x plus b0 a belongs to R to be. I suppose these questions are from the assignment 5, right? Okay, let me solve, then I will try to solve this question. Okay, a point in, so if it is hello Krishna, I am saying that if it is these are the question from the assignment 5, then actually I plan to solve it in the next tutorial, and I suppose these questions are from assignment 5, and if it is not from the assignment 5, then I will try here to solve it. Okay, yeah, then I am for this tutorial I just plan to solve the question assignment 4. In the next tutorial I will solve, so I will try to solve this question. First let me finish the question assignment 3, then I will try to solve, or I will here give a hint how to solve it. Question 9. So a point X is chosen at random from the interval 0, 1 with the probability density function if x is 1 0 and otherwise. The probability that first digit of x will be 3 is, what is the probability of this? So that means this point has to be in between greater than equal to 3 but less than equal to 4. So we have to calculate this probability, and what is this probability is nothing but 0.3 to 0.4. So 0.3 to 0.4, and for the uniform distribution, the probability density function fx is actually 1. So this is tx. So this is basically 0.4 minus 0.3. So this is 0.1, and that is 1 by 10. So that is the answer. Now last question, then I will try to solve the Krishna's question. And then question 10, that which of the following distributions has the memoryless property? So which of the distribution? So the distribution, exponential distribution, has the memoryless property. Let's check that thing. So what does the memoryless mean? Memoryless property mean that if let me write the what is the exponential function, distribution of exponential lambda to the power minus lambda t. Now what is the probability that these event occur at a probability at a x which is larger than t? This is nothing but 1 minus 0 to 1 minus probability of x less than equal to t. So 1 minus 0 to t lambda to the 1 minus lambda is ts. So this is 1 minus of 1 minus 0 to the 1 minus lambda t. So this is basically minus lambda t. Now memoryless, what is the probability that x will be greater than t plus alpha if it is also greater than t? If we already know that it is greater than t, sorry, I read me in another way. So if I know it is greater than alpha, what is the probability that it also greater than alpha? So from here we can write, this is suppose a, this is b. So a intersection b by probability of b. So basically x greater than t plus alpha will be a subset of this. So that means intersection will be simply p of x greater than t plus alpha by p of greater than b means greater than x greater than t. So this is e to the power basically minus lambda into t plus alpha by this alpha, e to the power minus lambda alpha. So this is e to the power minus t lambda t, which is basically p of x greater than t. So this doesn't matter from where we started. So that is called it doesn't matter from where we started. So that means, but only matter what is the difference between this initial and final stage. That means it's lost its memory. So this is called a memoryless property. So that's it. The exponential function has a memoryless property. Now let's move toward the question that has been asked by Krishna. So suppose x follows a normal distribution with mean 0 and standard deviation 2. Then the distribution of y, okay. So it is been asked that x follows a normal distribution, right? So x follows a normal distribution with mean 0 and standard deviation 2. Standard deviation 2. That means this will be 1 by root over 2 pi sigma e to the power minus x square by sigma square. Now the distribution of the distribution of y is equal to e to the power x. Then what is the distribution? What is the distribution of e to the power x? Y. Okay. These we have to find. Okay, so distribution of e to the power x, that means if we can calculate what is the probability that y greater than y, suppose y greater than some function t, they have to be Krishna, I have to think about it. I don't know the solution exactly in this moment, so I have to think about, because and the second question, let me, and the options are gamma function with mean and standard deviation, these gamma function with mean and standard deviation e minus 1, log with log normal with mean square and standard deviation root e. So the next question is, x b are normally distributed random variables with 0 and 4. The distribution of this, are you mean this is y a, distribution of y a x? I don't get that things, y a x, or it is simply a0 x plus b0, like these things. I don't know. The distribution of the y e to the power x. Okay, I so how we will calculate this? That means e, so this is basically, suppose this is the variable, so that x will be log y, right? So this means basically log y, x will be log y. So that means if suppose y should be greater than a, means x should be greater than log of a, right Krishna? So I think this is the way to solve it. I don't know exactly, let me try it. So suppose I have to calculate this distribution, that means x is actually log of y. So if I randomly generated x from this distribution, so suppose I get some value x, so what will be the corresponding y variable? Y variable will be e to the power x. So if I know y, so x will be log e base y. So that means x is a thing. So if I want to know what is the probability x greater than a, so probability of y greater than a means probability of x greater than a, probability of x should be greater than log of a. Now what will be then the probability that x greater than log of a, that is nothing but 1 minus probability of less than or equal to log of a, or simply that cumulative distribution function ft will be, what is the probability that x less than equal to log of t. So this is similar to that this is the cumulative distribution function of the probability that this is the, simply I got the point. So first let us calculate the cumulative distribution function. So cumulative distribution function p of this y, suppose y less than or equal to some function t is, that is same is probability of x less than or equal to log t. Now let's calculate it. What is the probability? And here x can be minus infinity to plus infinity, right? So minus infinity to plus infinity, but I have to calculate minus infinity to from log t f of x is ts. And this is minus infinity to plus log t if x is 1 by root 2 pi sigma e to the power minus x square, sorry s square or x square by sigma square dx. This is the thing. Now you have to derivative it. So with respect to t, if you get derivative, then so if you can calculate this, then the distribution function of this y fyt will be, because this is nothing but the cumulative distribution function. So if you know, so d dt of this fyt will be the distribution. So Krishna, did you do you get my point? So how can you solve this question? Okay, this is x base. Next I'll give you a hint the next how you solve the next question. So I think you get a hint how you will solve the question, the first question you asked, and I will solve that question in the next assignment. So I am not not solve the whole problem, but I am giving you a hint. So this way you can get the probability distribution function. Now from that distribution function you actually exactly get the standard deviation, and suppose then y is so you will first get the distribution, then from that you will also get the mean and standard deviation. So that's it. So you have to only do the integration and then differentiate with dt, then you will actually get the distribution of the log t. That's it. And next question is ax plus b. Okay, so next question is distribution of ax plus b. It's same question. Okay, so if the distribution is, if the x distribution is normal distribution, that means 1 by fx x is 1 by root 2 pi sigma e to the power minus x square by sigma square normal distribution. Now you have to calculate the distribution of ax plus b. Now again the simply you will see that x means that b, okay, it's I think it is also simple. I think it is it will also follow the normal distribution, but I think it is also follow the normal distribution, but you have to shift the origin, that's it. So x equal to y minus p by a. Now you see that this is a again increasing function of y, so it's monotonically increasing or whatever you will say. Then if you want to calculate the what is the probability that y is less than t, then you have to, that is actually equivalently x is less than t minus b by a, right, less than equal to, now it is actually again minus infinity to t minus b by a fx t fx x dx. Now you get the cumulative distribution function of the fyt. Now if you derivative with respect to time, you will get fyt d dt of fyt. You will get the distribution function, and I think it is again will come normal distribution with redefining this sigma and mean, and that's it. And I think you got my point. How will solve these questions, and normal distribution with mean b and standard deviation. I think from the simple thing you will actually know the mean will be shifted towards, because the expectation value, the expectation of y will be a expectation of x plus b. Since expectation of x is 0, so the mean will be b, and you have to calculate the standard deviation. Standard deviation is simply, standard deviation means, first you know, then expectation of y square is, expectation of y square is expectation of y square means expectation of a x plus b its square. So a x square plus 2ab x plus b square. So a expectation of x square plus 2ab expectation of x plus expectation of b square is b square. You know the expectation of x is 0, so expectation of x square also you know, that is, I think it is sigma, I think, right? It is expectation is variance of variance, you know, the expectation the variance, you know. So variance means variance of x means expectation of x square minus expectation of x its square. So since expectation is 0, so variance actually means expectation of x square. So that means, okay, now expectation of y, this is y square. So expectation of y square, so that means mu 2 prime is a x square means actually variance of x. So variance of x, suppose the variance of x is sigma square plus b square. Now what will be the variance? Variance is mu 2 prime minus mu 1 prime its square. So this will be a sigma square plus b square minus, what is the expectation of y? Expectation of y is simply b, so minus b square. So it will be a sigma square, and sigma square means it is here the variance is sigma square is 4, so I think a4 and b. So the answer will be the standard deviation. So if it is variance is this, okay, standard deviation means root over of variance, so that is sigma root a, and sigma root a, that's I think it is a square sigma square, right? I think it is a square sigma square, a square sigma square, a square sigma square, a square sigma square, a square, a square. So this is variance, so this is a sigma, and a sigma, I actually, you know, variance means 4, the variance means sigma square equal to 4, so sigma equal to 2, so this is 2a and b. So this will be a normal distribution with mean b and standard deviation 2a. So that's it. So that's how you solve the second question. Second question, solution of the second question actually easier. And the first question, you have to know the what is the distribution. You have to solve. You have to integrate and first found out the distribution function. Then you will get. I think Krishna, you will get my point. The second question, I solved the second question here. The first question is a little bit tedious. So that's it. So that's all. If you have any other question, you can ask me, or I will end this session here. Okay, if you have no further queries, so let me allow to leave this meeting. So thank you for joining. Yeah. Okay, let me wait for 2 minutes, then I will leave.